Over the past week, our narrator has enthusiastically described a wide variety of cosmic objects, the sun, planets, and other bodies that make up the solar system, stars of all sizes, from giants to dwarfs, mysterious brown dwarfs, distant exoplanets, spectacular supernovae, and vast clouds of gas and dust. But what ties all these objects together into a single whole? They all exist within one shared city, the Milky Way. Let's delve deeper into this idea. The Milky Way galaxy appears to us as an immense, flat, disc-shaped structure composed of gas, dust, and countless stars. It is truly a cosmic metropolis, stretching about 100,000 light-years across and several thousand light-years thick. Our Sun, a modest star, is just one among hundreds of billions that populate this celestial city, located roughly halfway between the galactic center and its outer edge, essentially on the galactic outskirts. The galactic disk is adorned with two major and two minor spiral arms that converge toward the galaxy's core. At the very heart of this disk lies what's known as the bar, an elongated, cylindrical concentration of ancient red stars. The narrator acknowledges that all this information might feel overwhelming but promises to explain each point in detail. A natural question arises: how did scientists uncover all these astonishing facts? As with most astronomical discoveries, it all begins with a simple act: stepping outside and looking up at the night sky. If you happen to find yourself in a completely dark location on a moonless night, you'll see a faint, hazy glow stretching across the sky. This glow varies in brightness depending on the region, and when your gaze falls upon the constellation Sagittarius, you'll notice the glow becomes significantly wider, forming a bulge roughly the size of a hand held at arm's length. This ethereal band, resembling a road or river and emitting a soft white light, has captivated many ancient civilizations. The ancient Greeks called it galaxias, meaning milky. Over thousands of years, this name stuck, and today we know it as the Milky Way. But what exactly is this mysterious glow? For centuries, it was thought to be a nebulous cloud or mist, until Galileo pointed his newly invented telescope toward it. To his astonishment, he discovered it was made up of thousands of stars, so closely packed and so faint that the naked eye couldn't distinguish them individually. That's why they appeared as a single, continuous glow. Clearly, there are far more stars in the sky than the roughly 6,000 visible to the unaided eye. But how many are there really, and what overall shape do they form? Scientists reasoned that counting stars in different directions might reveal this shape. If the galaxy extended farther in one direction than another, more stars would be visible along that line of sight. For centuries, star counts produced maps suggesting the galaxy was elliptical or disc-shaped, with the sun near its center. While this method was clever, it had a serious flaw: it ignored the presence of interstellar dust. As explained in the episode on nebulae, dust absorbs visible starlight, hiding stars from view. Imagine being in a smoke-filled room. You might think the room is smaller than it really is and believe you're at its center, even if you're standing right next to a wall. Globular clusters provided compelling evidence that something else was going on. These spherical groupings of stars orbit the galactic center, and they are far more numerous in one part of the sky than the opposite side. This wouldn't happen if they were evenly distributed in space. The simplest explanation was that they were evenly distributed, but we were far from the center. Measurements show the sun lies about 25,000 light-years from the galactic core, which lies in the direction of Sagittarius. And recall, that's precisely where the Milky Way appears brightest and widest. Could that be a coincidence? Now everything begins to fall into place. The Milky Way must be a flat disk with a central bulge, and the sun lies within this disk, far from its center. From our vantage point inside the disk, we see it as a broad band across the sky. When we look toward the center, in the direction of Sagittarius, we see the bulge as a large concentration, while the disk itself appears thin. Thus, when we gaze along the disk, we see far more stars than when we look above or below it, out into intergalactic space. But what about the disk itself? Does it have any internal structure? Or is it just a smooth, flat plate? Visible light makes this hard to determine, as dust severely limits our view. Looking into the disk, we can only see about 1,000 light-years before dust obscures everything beyond. However, the advent of radio astronomy changed that. The gas clouds where stars form emit a very narrow range of radio waves. By measuring the Doppler shift in these signals, how fast the gas is moving toward or away from us, and making reasonable assumptions, astronomers could estimate distances. The results were striking. The distribution of these clouds revealed that the Milky Way's disk is divided into spiral arms, enormous, curved structures stretching tens of thousands of light-years. All massive, bright, young stars, the celestial giants, also prefer to reside in these spiral arms, avoiding the quieter spaces between them. This makes sense. Like all stars, these giants are born in vast nebulae. But unlike smaller stars, their lives are short, ending in brilliant supernova explosions. Since most nebulae are concentrated in the arms, these massive stars naturally remain there, never straying far from their birthplaces before meeting their fiery ends. And here's where things get truly fascinating. Our intuitive idea of spiral arms as fixed structures made of stars and gas turns out to be wrong. If that were true, the arms would wind tighter and tighter over time, like thread wrapping around a spool, because stars and gas closer to the galactic center orbit faster than those farther out. Yet we know spiral arms have persisted for eons without showing signs of winding up. The reason is that spiral arms aren't static objects, they are more like traffic jams. Imagine a busy highway. If one car slows down, it causes a ripple effect behind it, slowing other vehicles in a chain reaction. This creates a wave moving against the flow of traffic, causing a buildup. Though individual cars eventually speed up and exit the jam, new ones keep entering from behind. For every car that leaves the front of the jam, another enters from the rear. So while each vehicle passes through, the traffic jam itself persists. Spiral arms work the same way. Perhaps an initial density wave, the jam formed due to a disturbance in the disk, like a collision between molecular clouds. Once created, this wave spreads outward like ripples from a stone dropped in water, then twists into a spiral due to the disk's differential rotation. Stars and gas clouds drift into the wave, bunch up slightly, pass through, and continue their orbits. Our Sun takes about 250 million years to orbit the galaxy, meaning it has completed roughly 20 orbits since its birth, passing in and out of spiral arms many times. That's why the arms don't wind up. They are waves made of objects, but the objects themselves are transient. There's another key effect. When a gas cloud enters a spiral arm, it may collide with another cloud ahead, like a cosmic traffic accident. Such collisions can trigger gravitational collapse, sparking star formation. The resulting stars are often massive, bright, blue, and hot. These stars shine brilliantly across vast distances, giving spiral arms their characteristic blue tint and lighting up surrounding gas. That's what makes the arms visible. Thus, spiral arms are stellar nurseries, places where stars are born, and this ongoing star formation helps maintain the galaxy's spiral shape. One might call it cosmic-scale crowdsourcing. Still, pinning down the exact number of spiral arms in the Milky Way remains challenging. For a long time, astronomers believed there were 2, but recent studies of star cluster distributions suggest 4. Experts still debate the matter, but regardless, there are also shorter spurs branching off the main arms. Our Sun resides just outside one such minor arm, known as the Orion Arm. Mapping the Milky Way's spiral structure is an ongoing, difficult task, akin to trying to map a volcano while standing inside it. Yet so far, we've done remarkably well. At the galaxy's center lies the bulge, and recent observations, show it's actually a cylindrical bar of red stars pointed nearly toward us, making it appear round. This region is very old. Star formation. There ceased long ago when the gas supply ran out. Unlike the spiral arms, where stars are still being born, all the blue stars in the bar died long ago in supernovae, leaving behind billions of less massive red stars. The bar likely stretches 20,000 light-years and exists due to the unique gravitational dynamics of the galactic disk. Unlike our solar system, where the Sun dominates gravity, the Milky Way's gravity is spread across a vast region. This distributed mass allows large-scale structures, like spiral arms and the central bar to form and persist. But unlike the arms, the bar rotates as a solid unit. Stars near its ends complete one orbit in the same time as those closer to the center. At the very heart of the Milky Way lurks a supermassive black hole, with a mass 4 million times that of our Sun. While this sounds enormous, it's actually a tiny fraction of the galaxy's total mass, which includes hundreds of billions of stars. Yet, as we'll explore in the next episode, this black hole may have played a far more significant role in shaping our galaxy's evolution than it first appears. Another crucial component of the Milky Way is its halo, a vast, spherical collection of stars extending more than 100,000 light-years from the center. Our knowledge of the halo is still limited, but we do know its stars are extremely old. There's no active star formation there, confirming their ancient origins. Some halo stars likely formed in place, while others were flung outward during collisions with other star clusters. Notably, most of the globular clusters orbiting the Milky Way reside in the halo, numbering over 150. So now we have a clearer picture of our galactic city. But like a resident of a small town, we naturally wonder, is this all? What lies beyond? At the start of the 20th century, astronomers faced the same dilemma: is the Milky Way the only galaxy, or just one among many? In this Crash Course Astronomy, we're about to take a truly monumental step. Get ready, in the next episode, we'll begin exploring the expanding universe. Today's lesson has shown us that the Milky Way is a disk galaxy, a colossal assembly of dust, gas, and hundreds of billions of stars, with our Sun situated roughly halfway from the center. Its disk features grand spiral arms shaped by stellar and gaseous traffic jams, where new stars are constantly being born. The central region forms a bar dominated by red stars, and surrounding it all is a halo populated by ancient stars. This episode of Crash Course Astronomy was produced in collaboration with PBS Digital Studios. For more fascinating videos, visit their YouTube channel. This episode was written by Phil Platt, edited by Blake DePartino, and Dr. Michelle Tholler served as our expert consultant. Directed by Nicholas Jenkins, edited by Nicole Sweeney, with sound design by Michael Aranda and graphics by Thought Cafe.